Okay, so ready to dive into something really groundbreaking.
I am.
You guys sent us this fascinating project from Singapore.
Yeah.
And honestly, it's turning heads in the world of physics education.
No, it's really cool.
Like, seriously, we're talking an Innergy Award winner.
Wow.
That's like
That's a big
the
deal.
Nobel Prize for Innovative Teaching.
Huge.
And honestly, once you hear what they've done,
Okay.
you'll completely understand why.
I'm ready.
So,
Lay it on me.
what's fascinating about this project
Okay.
is that this team from Singapore tackled a problem that's plagued physics teachers for ages.
Right.
How do you make gravity, something that we all experience every single day,
Right.
really come alive for students in the classroom?
Yeah, because it's one of those things, it's all around us,
Exactly.
but it's hard to get a grasp on.
Well, especially because just staring at equations in a textbook, it doesn't exactly scream exciting, does it?
No, not at all.
But this team found a solution.
Oh.
They created 4
Okay.
free interactive computer models,
Okay.
simulations that let students explore gravity in a way that's never been done before.
Oh, wow.
So we're not talking like your average educational computer game.
Right.
These simulations are built using real astronomical data from NASA,
Oh, wow.
and they're designed to directly align with the Singapore physics syllabus.
So they're really high quality.
Yeah.
And they're really targeted.
Exactly.
That's great.
And they're addressing specific areas where traditional teaching methods just fall short.
I see.
For example, one of the simulations tackles Kepler's third law of planetary motion,
Oh, yeah.
which can be a real head-scratcher for students.
Definitely.
Oh, I remember struggling with that one back in school.
I can imagine.
It describes the relationship between a planet's orbital period, so the time it takes to go around the sun, and its distance from the sun.
Right.
But just seeing that formula on a page, it didn't really click for me.
Yeah, it's very abstract.
But in this simulation, students can actually build their own solar systems, change the mass of the planet,
Oh, wow.
tweak its orbital radius, and see in real time how that affects its year length.
So cool.
They're bringing Kepler's law to life,
That's awesome.
and we've got research papers, conference presentations. We've even got glimpses into actual student work using these simulations.
Oh, very cool.
So we're going to unpack all of that today.
Sounds good.
By the end of this deep dive, you'll not only understand how these simulations work,
Uh-huh.
but also why they're making such waves in the educational world.
Yeah, I'm really interested to hear about that.
And why this matters for anyone who cares about learning and the future of education,
Right.
even if physics isn't your thing.
I'm with you.
Because the impact goes way beyond just one classroom in Singapore.
Okay.
This team has presented at international conferences.
Wow.
They've published their research.
That's great.
They've even collaborated with the open source physics community, contributing to a global movement of educators who believe in making science more accessible.
It's awesome that they're getting this kind of recognition.
I know, right?
Yeah.
And they're seeing amazing results.
Like what?
We're talking about 75% of students
Wow.
feeling the simulations exceeded their learning needs,
That's huge.
and almost half reporting that it helped prepare them for life beyond exams.
So it's not just about testing.
No,
It's about actually being able to use the knowledge.
it's about fostering a deeper understanding,
Right.
sparking curiosity, and empowering students to think like scientists.
I love that.
All right, so we've got this incredible project. We've
Yeah.
got the big picture impact,
Uh-huh.
but let's get down to the nitty-gritty.
Okay.
What makes these simulations so special?
Yeah.
How do they actually work?
I'm ready. So they've cleverly designed each simulation to address specific challenges in understanding gravity.
All right.
Remember we talked about that Kepler model for planetary motion? It's not just about moving planets around.
Right.
They've made it so you can adjust a planet's mass
Okay.
or its orbital radius, like how far it is from the sun,
Yeah.
and instantly see how that changes how long its year is.
So students can actually experiment and see Kepler's third law in action,
Exactly.
not just memorize it.
Right.
That's really neat.
It turns abstract formulas into something tangible and interactive.
Yeah.
But that's just one of 4 simulations.
Okay.
Another one tackles the concept of geostationary satellites.
Okay, I'll admit I've always been a bit fuzzy on that one.
Oh, yeah.
Are those the satellites that stay in the same spot in the sky?
Yeah.
Like for TV signals and stuff?
Exactly.
Okay.
And the geostationary satellite model helps students visualize why that happens.
Okay.
They can play around with different orbital speeds and altitudes
Mhm.
and see how those affect the satellite's path.
Okay.
It demonstrates that to stay above the same point on Earth,
Right.
a satellite needs to orbit at a very specific speed, matching Earth's rotation.
That makes so much sense now.
I don't know, right?
I wish I had this when I was in school.
Me too.
It's amazing how a visual, interactive experience can make such a difference.
For sure.
And then there were the two one-dimensional gravitational models,
Yeah.
which delve into even more complex ideas.
Right.
Like what?
Things like gravitational strength and potential.
Yeah.
These are concepts that are notoriously hard to grasp,
No, I
even
know.
for students who are good at math.
Yeah.
They involve thinking about invisible forces
Uh-huh.
and how they change depending on the mass of objects and the distance between them.
Yeah. Okay.
So how do these simulations help with that?
Yeah. How do they?
Imagine being able to visualize the gravitational field lines
Right.
between objects,
Mm-hmm.
seeing how they become denser, meaning the force is stronger,
All right.
as you get closer to a massive object.
Okay. I'm starting to get the picture.
And the simulations let you change the masses of the objects
Yeah.
and their positions
Okay.
and see how that affects the strength of the field.
Okay.
You can even plot graphs to see how gravitational potential changes with distance.
So they're taking these really abstract ideas
Yes,
and making them visible and interactive.
precisely.
And the fact that they've integrated these simulations directly into the curriculum
Yeah,
means teachers can use them in a really targeted and structured way.
exactly.
And the students aren't just passively watching, right?
Nope.
They're actually participating in the learning process.
Absolutely.
They're asking questions,
Right.
testing hypotheses,
Mhm.
tweaking variables, and drawing their own conclusions.
Yeah, they're essentially becoming scientists
Yeah.
in a virtual lab.
And from the feedback we've seen,
Yeah,
the students are loving it.
they are.
And it's not just anecdotal.
Right.
The team collected data from a class of 20 students who used these simulations.
Okay.
Over 70% reported enjoying the lessons.
Wow, that's great.
And 75% felt the simulations helped them understand the material better than traditional methods.
That's awesome.
That's fantastic.
Yeah.
But is it all just about having fun?
Right.
Are they actually learning more?
Yeah, are they actually retaining it?
Yeah.
The data suggests they are.
Okay.
Remember that almost half the students reported that the simulations help prepare them for life beyond exams?
Oh, wow.
That means they're not just memorizing facts,
Yeah.
they're developing a deeper understanding of these concepts and seeing how they connect to the real world.
That's what we love to hear.
I know, it's so great.
So we've seen how these simulations work.
Yeah.
We've seen the positive impact they're having on students.
Mm-hmm.
But this team isn't stopping there.
No.
They have a much bigger vision, don't they?
They do.
It's really exciting to think about all the possibilities.
Yeah.
Like, imagine a history class where you could actually walk through ancient Rome,
Right.
not just read about it.
That-
Or a biology class where you could like zoom in on a 3D model of a cell
Yeah.
and actually see all the organelles in action.
It'd be amazing.
It's like it opens up this whole new world of learning.
And this team from Singapore has shown us it's possible.
Yeah.
I mean, they created these incredible physics simulations,
Yeah.
but they're not stopping there.
Right.
They're actively encouraging other educators to join this movement and create similar resources for other subjects.
Yeah. And the best part is
Yeah.
they're not keeping these resources to themselves.
Right.
They're sharing them freely with the world.
Yeah, through open source platforms and educational databases.
Exactly. Like, remember they even had a Wikipedia entry.
Oh, yeah, that's right.
That's how committed they are
Yeah,
to making this knowledge accessible to everyone.
that's incredible.
It's such a powerful example of what can happen
Yeah,
when people are passionate about education
right.
and willing to share their ideas and their expertise.
And it makes you wonder, like, if this kind of interactive,
Mhm.
inquiry-based learning is so effective,
Yeah,
why isn't it more widespread?
that's a great question.
What are the barriers holding us back?
Yeah, like what is it? Is it a lack of funding?
Maybe.
Is it resistance to change?
It could be.
I mean, we're so used to the traditional model of like lectures and textbooks.
I think it's probably a combination of factors.
Yeah,
Developing these simulations takes time, expertise, and resources.
right.
Not every school has the budget or the technical know-how to create them from scratch.
Yeah.
And let's be honest, some teachers might be hesitant to adopt these new methods,
Yeah,
even if they see the potential.
that's true. But this team has proven that it can be done,
Right.
even with limited resources.
Yeah,
And they're providing a blueprint for others to follow.
exactly.
They're showing the world what's possible.
They are really leading the way.
Yeah.
So what does this all mean?
Yeah. What's the takeaway for our listeners?
I think the key message is that we need to rethink what education can be.
Okay.
We need to move away from passive learning
Huh?
and embrace active, inquiry-based approaches
Okay.
that empower students to explore, experiment, and discover for themselves.
Yeah.
And technology can be a powerful tool in that process.
For sure. And it's not about replacing teachers with computers.
Yeah.
It's about giving teachers the tools they need
Right.
to create truly engaging learning experiences for their students.
Exactly. And it's about fostering a love of learning that goes beyond memorizing facts for a test. It's about inspiring students to be curious, to ask questions, and to see the world around them in a new light.
That's beautifully said.
Thank you.
And I think this project from Singapore is a shining example
Yeah.
of what that kind of education can look like.
It really is inspiring.
All right, listeners, we've reached the end of our deep dive into this incredible project.
Yeah.
But we want to leave you with one final thought to ponder.
Okay. Hit me.
We've talked about the amazing potential of these simulations for physics.
Yeah.
But what other subjects could benefit from this approach?
It's a good question.
What if every student had access to virtual labs that brought every subject to life?
Wow. Yeah.
What kind of world could we create
Right.
if we unleashed that kind of learning power?
I love that.
We'll leave you to think about that.
Yeah.
Until next time, keep exploring, keep learning, and keep diving deep.
See you next time.